third formula, if y is equal to log x plus b, yn is equal to minus 1 raised to n minus 1, n minus 1 factorial a raised to n upon x plus b raised to n. So how this formula is proved? Now you keep one thing in the mind. For board syllabus, when we are solving the example, you follow this method, proof method. And for JEE, any competitive exams, you are to directly want to reach the objectives. In that, you keep the formulae, and in engineering also, you keep the formulae this in mind, and directly you apply the formula for that type of the example. Instead of this A, B, etc., there are some constants are coming. So use the formula and comparatively put the values there. So that difference you give this. So these proof methods you follow for board exams, and formula methods use standard formula directly for competitive exams where you are solving the objectives, and in engineering also. So y is equal to log of ax plus b. So if we differentiate, y1 is equal to 1 upon ax plus b into derivatives of x plus b is a. y2 is equal to minus 1 upon ax plus b bracket square into derivatives of ax plus b is a, and this a means a square. y3 is equal to 1 upon ax plus b raised to 4 into derivatives of this ax plus b square 2 into ax plus b into derivatives of x plus b is a, and this a square, so a cube. Now if we standardize this, now when n is equal to 1, 1 is 1, 1 is here, n is equal to 2 then and so on. So we can write n minus 1 factorial. 1 minus 1, that is here we will write 0 factorial. A divided by ax plus b. We will write here, now this is here positive sign, now minus 1 factorial a square upon ax plus b square of that, and this result 1 into 2 factorial, so 2 factorial a cube ax plus b bracket cube. So from this result we can generalize, by generalization, yn is equal to, now here the signs are coming, where n is equal to 1 positive sign, alternating series, summation, plus, minus, plus, sequence is coming like this, minus and so on. So here first is the positive, n takes the value 1, so we can write the summation minus 1 raised to n minus 1, n is equal to 1 to n. So we write here for sign minus 1 raised to n minus 1. Now when 2 factorial, 1 factorial, so we can write n minus 1 factorial. When n is equal to 1, a raised to 1, 2, a square, 3, a cube. So we can write a raised to n and divided by ax plus b raised to n. So like this we will get the formula for logarithmic function. Again I am telling, for board you follow the example solving like this method, and for competitive exams, JEE, CAT, BEAT, any competitive objective questions you are solving, use the formula directly. So you keep this formula also mind, as we are keeping the derivatives formula in mind. Now next we will see if y is equal to a raised to mx plus c, yn is equal to, we can write a raised to n, a raised to mx plus c log m raised to n, a raised to mx plus c and log a raised to n. Now we prove this formula. So y is equal to function a raised to mx plus c, suppose. Yeah, m, c are constants. If we differentiate, y1 is equal to, we get a raised to mx plus c log a, and derivative of mx plus c is m, composite function. y2 is equal to a raised to mx plus c, and this is constant. Derivative of this again log a square and m square. y3 is equal to, we get a raised to mx plus c log a bracket cube m cube. So m a raised to mx plus c log a m square log a raised to mx plus c log a square of that m cube a raised to mx plus c log a bracket cube. Suppose first, second and third. Now by observing these first three results and by general logic, we'll write the nth derivative. So by generalization, yn is equal to, so where a is equal to 1, m power is 1, 2, 2, 3, 3. So we can write m raised to n. A raised to mx plus c, constant in three results. Now when a is equal to 1, power of log is 1, 2, 2, 3, 3. So log a raised to n for nth derivative, and that is the result. Is proved. Now next, we see this for trigonometric function. If y is equal to cos ax plus b, you know yn is equal, on the same manner we prove for e raised to mx plus c. Yn is equal to a raised to n cos ax plus b plus n pi by 2. So this is the standard formula. Now how this formula is coming, we'll see this proof. So into other standard board syllabus, when we are solving the paper, you follow this method. So y is equal to cos ax plus b. y1 is equal to first derivatives minus sine, derivative of cos is minus sine, ax plus b into derivative of x plus bj. Now we will standardize this result. So this we can write a cos ax plus b plus pi by 2. So you know this ax plus b is acute angle, and in that pi by 2 is added, ratio is changing to the sign, and second quadrant cos is negative, so minus sign. We will use our right angles concept. So y2 is equal to, now take the derivatives of this. So y2 is equal to a minus a sine ax plus b plus pi by 2 into derivative of x plus b is a. So we can write the standardize this result. Okay, I will write here this is cos ax plus b plus pi by 2. So this is a cos a into a square cos ax plus b plus 2 pi by 2. y3 is equal to, we can write a cube cos ax plus b plus 3 pi by 2. Directly we will write by observing this first two derivatives. So if we observe this first result, second result and this third result, and we will generalize the result for nth derivatives. So by generalization, yn is equal to a raised to n cos ax plus b plus n pi by 2. That is the result, hence proved. On the same manner, you can find nth derivatives of sin x plus b, that is yn is equal to get sin x plus b plus n pi by 2. Now one formula will prove this. If y is equal to e raised to x sin bx plus c, then yn is equal to, you know this, r raised to n e raised to ax sin bx plus c plus n phi, where r is equal to under root a square plus b square and phi is equal to tan inverse b by a. On the same manner, we are getting the formula for e raised to x cos bx plus c. Now, if we prove this, so we prove this formula, prove y is equal to e raised to x sin bx plus c. So yn is equal, y1 is equal to, we get UV formula here we use e raised to x constant, derivatives of sin cos bx plus c into derivatives of bx plus c is b, plus sin bx plus c will keep the constant and derivative of e raised to x into a. Now e raised to x common will take outside into bracket a sin bx plus c and plus b cos bx plus c. Now we'll generalize this in this form. So for that, here cos is required, here sin is required. So we'll use the trigonometric substitution. So here cos is required a, here sin is required, so b. Now by Pythagoras, this is under root a square plus b square. So here suppose this angle if you consider phi, so phi tan phi is equal to b upon a. So phi is equal to, we get tan inverse b by a. We are putting phi is equal to tan inverse b by a, and this is r is equal to under root a square plus b square. Now sin phi, so therefore a is equal to r cos phi and b is equal to r sin phi. Now we will introduce these values here. So therefore y1 is equal to, we get e raised to ax r cos phi sin bx plus c plus r sin phi cos bx plus c. So that is equal to, now r common we take outside, e raised to ax into sin bx plus c plus phi. If we differentiate this again with respect to x, y2 is equal to r constant e raised to x into derivative of sin is cos bx plus c plus phi into b plus sin bx plus c plus phi constant and derivative of e raised to x into derivative of x is a. So y2 is equal to, we get e raised to x common will take outside, r e raised to x into bracket a sin bx plus c plus b cos bx plus c. So by putting these A and B values, r e raised to x, r cos phi sin bx plus c plus r sin phi cos bx plus c. So that is equal to r into r square e raised to x and sin bx plus c, sin a plus b formula we are using, sin cos plus cos sin. So bx plus c plus phi, this here phi, bx plus c plus phi. Plus phi. So phi plus phi will get 2 phi. So from equation first and second, by generalization, yn is equal to r raised to n e raised to ax. So when 1 r power is 1, when n is equal to 2 r power is 2. So when n is equal to n power. So r raised to n e raised to ax sin bx plus c plus n phi, where r is equal to under root a square plus b square, phi is equal to tan inverse b by a, and that is the proof of this result, hence proof. On the same manner, we can prove the result for y is equal to e raised to x cos bx plus c. So these are the proofs of the formula for nth derivatives. So this method you want to follow for the board syllabus of the 12th standard. Now here, next period, we will see how we solve the examples for JEE and all other competitive exams, and also in engineering. So how we will solve the examples directly by using the formula.